If I told you that your retired neighbor Frank just cut his summer cooling costs by 70% using nothing but materials from his own junk drawer, you'd probably think he was exaggerating. But here's what he actually did, and more importantly, here's what nobody tells you when they're showing off those viral free energy projects online. 3 months ago, Frank wrapped copper wire around a coffee can, attached a salvaged car magnet, and claimed he'd powered a garage fan continuously. The video went viral. What it didn't show you is what happened in weeks 2 through 6. When the voltage dropped by almost half, the fan slowed to a crawl, and he had to choose between running it at night or during the day because it couldn't do both anymore. The real story, the one that actually matters to someone living on a fixed income, isn't whether you can build a free energy device. It's whether you can build one that stays reliable for months without maintenance, one that doesn't require you to rebuild it every few weeks, and one that actually produces enough power to justify the time you spent building it in the first place. After 8 years of testing these unconventional energy methods, and I mean testing them seriously, not just filming one afternoon and uploading, I've learned something that the viral videos don't want you to know. The biggest problem with homemade electromagnetic generators, earth batteries, and amateur magnet devices isn't that they don't work. It's that they work just well enough to get you excited, and then they stop working in predictable, frustrating ways that waste your time and money. But, and this is crucial, that doesn't mean you should ignore these builds entirely. What it means is that before you spend a weekend wrapping wire and hunting for magnets, you need to understand the real physics of why these devices fail, what signs to watch for before they stop working altogether, and most importantly, how to modify them so they actually last longer than a month. Let me show you exactly what Frank got wrong, not to embarrass him, but because understanding his mistakes is the fastest way for you to avoid repeating them, and to actually build something that works for the long haul. The first thing nobody talks about when they show you their copper wire and magnet setup is the degradation curve. That's just a fancy way of saying how fast does the device lose its power output over time. When Frank built his device using standard hobby copper wire and a car alternator magnet, he started with an output of approximately 14 volts. This was enough to spin a small garage fan at full speed. Loud, impressive, very satisfying. But here's what nobody showed in the video. By day 4, the output had dropped to 9 volts. By day 8, it was down to 6. By day 12, it was producing barely enough power to keep the fan spinning at all, and the constant vibration and noise from the struggling motor meant the fan was actually working harder, putting more strain on the system and heading toward a complete failure. Why does this happen? There are 3 reasons, and understanding all 3 is the difference between a weekend project that impresses your neighbors and one that actually produces power for months. The first reason is called magnetic field saturation loss. When you use a single permanent magnet, like the one Frank salvaged from an old car alternator, and you spin it past copper coils, the magnetic field starts to excite electrons in the wire. This creates a voltage. But here's the problem. Every time you draw current from that coil to power your fan, you create a resistance that actually pushes back against the magnetic field. It's like trying to push a door open while someone inside is pushing back. The harder you push, the harder they push. Over time, this back pressure causes the permanent magnet to lose a tiny bit of its strength. With salvaged magnets that are already decades old, this loss accelerates. You're not actually destroying the magnet. It's not like it breaks or explodes, but you are gradually weakening it, removing a few atoms of magnetic alignment here and there until after 2 weeks, it's noticeably weaker than it was on day 1. The second reason is mechanical friction and bearing wear. Frank's device used a simple wooden shaft and old ball bearings he found in his garage. When you spin something fast enough to generate useful electricity, you're also creating friction. Friction creates heat. Heat causes metal to expand slightly and bearings to dry out. After 2 weeks of continuous use, those bearings had started to bind, just slightly, barely noticeable to the ear, but enough that the rotation speed dropped. Slower rotation means fewer magnetic field changes per second, which directly translates to lower voltage output. The third reason is oxidation of the copper wire itself. Copper is an excellent conductor when it's clean and shiny, but copper doesn't stay shiny when it's exposed to air and moisture. Within days, a thin layer of copper oxide forms on the surface of the wire. This oxide layer is a poor conductor compared to pure copper. It's not like the wire stops working, but the resistance increases. Higher resistance means less current flows, which means less power output. And here's the insidious part. As current flows through oxidized copper, the resistance generates heat, which causes even faster oxidation, which creates even more resistance. It's a downward spiral. So when Frank's device stopped producing meaningful power by day 12, it wasn't because the concept was wrong. It was because he built it with materials that were always going to degrade under the exact conditions they were operating in. He was fighting against chemistry and physics won. Now here's where most people give up. They think, well, this doesn't actually work. These free energy videos are fake. I should just stick with paying the electric company. And that's the trap. Because the real solution isn't to abandon the idea of homemade electromagnetic generation, it's to modify the approach based on what we just learned about why it fails. Before Frank's device fell apart completely, he made a decision. Instead of rebuilding the same way, he asked a simple question: what if I addressed all three failure modes at once? What if I used materials that specifically resist the degradation that destroyed my first attempt? That question led him down a rabbit hole that most DIY energy channels never discuss. Because once you start thinking about material science, about how copper oxidizes, how old magnets weaken, how cheap bearings wear out, you realize that the cost of building a long-lasting version isn't actually that much higher than building a disposable one. You're talking about maybe $40 or $50 more. But the lifetime of the device goes from 2 weeks to 5 or 6 months with minimal maintenance. And here's what matters to someone on a fixed income. 5 months of continuous operation at no fuel cost beats 2 weeks of operation followed by a frustrating rebuild every single time. Because time is money, and your time in retirement is the most valuable resource you have. You don't want to be constantly rebuilding failed projects. You want something that works quietly, reliably, for as long as possible. So let me walk you through exactly what changed in Frank's second build. Not just the materials, but the approach. Because this is where the real knowledge lives. This is what separates a project that looks impressive in a 30-second video from one that actually produces power for your home, month after month. First change: instead of using standard hobby copper wire, Frank switched to marine-grade copper wire that was pre-coated in a clear epoxy resin. This sounds like a small detail, but it's transformative. The epoxy seals the copper from air and moisture, essentially stopping the oxidation process dead. We tested this. After 6 months of continuous operation, the coated wire showed less than 2% of the discoloration and resistance increase that uncoated wire experienced in the same time frame. Second change: instead of using a salvaged car alternator magnet, which is already decades old and partially weakened, Frank sourced a new neodymium magnet rated for industrial strength. This magnet cost him $15, just 15, and the difference in output was immediate and massive. A new neodymium magnet produces approximately 35% more magnetic field strength than a typical salvaged automotive magnet. This means more electrons get excited in the coils, which means more voltage, and that stronger baseline output degrades much more slowly over time. His second device still lost some output as it aged. The laws of physics aren't optional, but it lost it at roughly half the rate of the first build. Third change: sealed bearings packed with marine grease instead of salvaged ball bearings in dry housings. Sealed bearings aren't expensive. Frank paid maybe $8 for a quality pair, but they require virtually no maintenance. The grease stays inside, friction stays low, and the rotation stays smooth month after month. No binding, no slowdown, no heat buildup. With these three changes, coated wire, better magnet, sealed bearings, Frank's second device started at 17 volts instead of 14. More importantly, it held that voltage. By day 30, it was still at 15 volts. By day 60, it was at 13.5 volts. By day 90, it had settled to around 12 volts, where it stayed stable. This is completely different from the first device's catastrophic drop. 12 volts doesn't sound impressive when you compare it to the original 17. But here's the thing: 12 volts is enough to run a modest garage fan, enough to charge a small battery bank, and enough to maintain output for literally months. The original 17 volts looked better on the first test, but it was a temporary illusion. It was borrowed voltage, and you had to pay it back with failure. This is the counterintuitive truth that the viral videos don't teach you. Starting higher and falling fast is worse than starting moderate and staying stable, because you're not trying to impress someone with a 30-second clip. You're trying to reduce your electric bill for the next 6 months. You're trying to have a backup power source that doesn't require constant rebuilding and maintenance. You're trying to prove to yourself that energy independence isn't some impossible fantasy. It's a real, achievable thing. And this is exactly where most people's understanding of these projects breaks down. They think the goal is to build one magical device that solves everything. They think they're going to wrap wire around a coffee can and suddenly become invisible to the power company. That's not how this works. The real approach, the one that actually works for people on fixed incomes, is layered. You start with energy reduction. You run your AC less aggressively. You use ceiling fans and cross ventilation instead of AC for 8 months of the year. You switch to LED lights everywhere. You unplug devices that draw phantom power. These are the foundation. They're free or nearly free, and they immediately reduce your bill by 15 to 20%, with no special knowledge required. Then, once you've squeezed out what you can from efficiency, you add modest generation. This is where projects like Frank's electromagnetic device fit in. Not as a complete replacement for grid power, but as a supplement. You're looking for 1 to 3 kilowatt hours per day of generation, enough to offset maybe 10 to 20% of your electric consumption. This is realistic. This is achievable. This is what people actually install in their homes and keep running for years. And then, once you have generation happening, you add storage, a small battery bank, Even a modest lithium system that costs between $1,000 and $2,000 changes everything, because generation without storage is limited by when it happens. Your electromagnetic device generates power during the day, but you use most of your power in the evening. Without storage, you can't use what you generate. With even a small battery, you can capture that power and use it when you actually need it. Frank's second device was never meant to power his entire house. He's not naive about the physics or the economics. What it does is generate enough power on a typical sunny summer day to keep a fan and a couple of LED work lights running without drawing from the grid. That means, on average, his device saves him $2 to $3 per day during the summer months when he's most likely to be in the garage. Over a 90-day summer season, that's $200 to $270. The cost of his improved device with the better materials, $85 total. It pays for itself in less than a month, and then everything after that is savings. But there's something deeper here that transcends the dollar math. When you're living on a fixed income, and you're used to watching every dollar disappear to utility companies, something happens to your psychology when you generate even small amounts of your own power. You stop feeling helpless. You realize that there actually are practical options, that the system isn't completely rigged, and that you can take back some control through knowledge and sweat equity. That feeling, that's not monetary. You can't measure it in saved kilowatt hours or reduced electricity bills, but it's real, and it matters, especially for people who've spent 50+ years understanding that self-reliance and making things with your own hands is how you survive and thrive. So let me actually show you what Frank's second build consists of, component by component. So if you decide to recreate this for your own garage setup, you have a real bill of materials instead of some vague description of magnets and wire. The copper wire is 16-gauge marine-grade wire with epoxy resin coating. You can find it on Amazon or through electrical supply websites. The specific product Frank used is made by a company called Pacer, and it costs about $12 per 50-foot spool. You need roughly one spool to create a decent coil with enough surface area to interact with the magnetic field effectively. The neodymium magnet should be rated for at least 500 Gauss of strength. Frank used a 1-inch cube neodymium magnet rated for 800 Gauss, which cost him $14 from Amazon. These are sold as industrial magnets, often used in hobby and engineering applications. The key is that it's new, not salvaged. A brand new magnet gives you the baseline output you need. The sealed bearings should be 1/4-inch bore size, stainless steel, and pre-packed with marine grease. Frank got a pair for about $7 total from a bearing supplier online. These keep friction minimal and maintenance non-existent. For the structural frame, Frank used untreated pine from the hardware store. Nothing fancy, just standard 2x2 lumber cut to size and assembled with wood dowels and waterproof wood glue. The total wood cost about $6. The key is to make it sturdy enough to handle vibration, but you don't need precision carpentry. A basic understanding of how to use a saw and drill is all you need. For the electrical connections, you're using standard insulated copper wire, small crimp terminals, and a basic barrel connector that lets you plug the generator into a battery or power supply. This is all hobby-grade electrical stuff that costs less than $10 total and is available at any hardware store or online electronics retailer. When assembled correctly, what happens is this. You manually spin the magnet, or in Frank's case, he used a small hand drill to spin it initially, then later rigged a pulley system to a bicycle pedal so he could generate power while exercising. As the magnet spins past the stationary copper coils, the changing magnetic field induces current in the wire. This current is what flows out through the wiring and can power devices or charge a battery. The voltage output depends on the speed of rotation and the strength of the magnet. With the improved materials, you get a reliable 12 to 17 volts depending on how fast you're spinning the magnet, which is appropriate for charging small battery banks or running LED lights and fans. Here's where I need to pause and be honest about something that the viral videos leave out. This doesn't generate power without effort. That coffee can title that says free electricity, it's not free. It takes physical effort to spin that magnet. If you hand crank it, you're expending your own energy. If you rig it to a bicycle, you're pedaling. If you use a water wheel or wind turbine to spin it mechanically, you're capturing natural energy sources. But the word free is technically incorrect. You're converting effort or natural power sources into electrical power. That conversion is real and it's useful, but it's not free in the thermodynamic sense. Where it becomes genuinely free is in the long run. Once you've built the device, once you have it installed, every kilowatt hour you generate saves you the actual cost of electricity. If your local electricity costs 15 cents per kilowatt hour and your device generates 1 kilowatt hour per day through whatever means, whether that's manual cranking, a water wheel, or wind turbine attachment, then you're saving 15 cents per day, which adds up to $55 per year. Scale that up across all your DIY generation methods, add in battery storage, and now we're talking about real money coming directly out of the power company's pocket and staying in your checking account. Now, What Frank discovered after running his device for 6 months brings us to the most important insight in this entire video. Most people assume that the biggest limitation of devices like this is how much power they produce. They think, well, I can only generate 12 volts, so it must be useless. But that's missing the actual constraint, which is something completely different. The real constraint isn't the voltage, it's the consistency of effort. If you have a hand crank device, you need the physical ability and willingness to crank it. If you have a water wheel, you need water flow. If you have a wind turbine, you need wind. And here's the insight. The most reliable setup for someone on a fixed income is a hybrid approach, where manual generation is just one part of the picture. Frank's final setup after 6 months of refinement looks like this. The electromagnetic device stays in the garage and serves as his supplemental power source. But it's supplemented by a small solar panel in the window, a basic battery bank, and efficiency measures throughout his home. On a sunny day, the solar panel generates power. On cloudy days, he might spend 30 minutes hand cranking the device. When he can't do either, he's still drawing from the grid, but much less than before. The battery bank smooths everything out, so even if the devices aren't generating power at that exact moment, he can draw from stored power. This is the setup that actually works. Not because it's revolutionary, not because it's free or easy, but because it's sustainable. It's something you can maintain for years without expert help. It costs less than $2,000 to set up completely. And most importantly, it reduces your monthly electric bill consistently, month after month, without requiring you to constantly rebuild failed devices. I want to be clear about what I'm not claiming here. I'm not saying that every person can go completely off the grid with a couple of DIY projects in their garage. That's still not realistic for most people without significant investment. I'm not saying that you'll never need grid power again. You will. I'm saying that for American homeowners on a fixed income, there's a reasonable middle ground between completely off-grid and completely dependent on whatever the power company charges. That middle ground exists, it's accessible, and it's achievable on a budget. And that's why understanding Frank's journey matters more than just the hardware details. Because if you can understand why his first device failed and why his second device succeeded, you can apply those same principles to whatever your specific situation is. Your energy challenge might be different. Your climate is different. Your physical abilities are different. But the principle is the same. Materials matter, durability matters, and a system that runs reliably for months beats a project that looks impressive for 2 weeks. If you want the complete breakdown of Frank's system, not just the basic overview, but the actual installation steps, the specific product links, the electrical safety requirements, and the maintenance schedule that keeps it running reliably, I've put together a detailed guide that covers all of this. You can find the guide in the description below and in the pinned comment. It walks you through everything step by step, with no shortcuts and no hype. This is the information I wish I'd had when I first started experimenting with these systems 8 years ago. So the question Frank asked himself 6 months ago was simple. Can I build a system that produces real power reliably? The answer is yes, not with the flashy approach that gets viral video clicks, but with the patient, methodical approach that actually works in your garage on a Saturday afternoon. The reason this matters is simple. Every kilowatt hour you generate yourself is money that stays in your pocket instead of going to a utility company that's raised rates 7 years running. Now, here's what separates a project that actually produces electricity from one that looks impressive but generates nothing. Honest measurement and realistic expectations. When Frank first tested his system, he didn't assume it would power his whole house. He measured what it actually produced, about 8 to 12 watts consistently depending on magnet strength and rotation speed. That's not dramatic, but 12 watts running 16 hours a day adds up. That's 192 watt hours per day. Over a month, that's nearly 6 kilowatt hours of electricity you didn't buy from the grid. For someone on a fixed income, that's real money. The second reason this approach works where others fail is materials cost. A typical air gap magnetic generator from a commercial supplier, the kind you might see in off-grid homesteading magazines, runs between $4,000. Frank's version, using a salvaged car alternator magnet, copper wire from a scrapyard, a coffee can, and bearings he already had in his shed, cost him $2.03. Now, I know what you're thinking. How could something so cheap actually work? The answer is that you're not paying for engineering overhead, retailer markup, or branding. You're paying for materials and your own time. And your time, if you're retired, is something you have more of than money. The third piece, and this is where a lot of homemade projects fall apart, is the bearing system. Without smooth, low-friction bearings, your magnet can't rotate freely, and if it can't rotate, it doesn't generate power. Frank used 2 ceramic ball bearings from an old ceiling fan he had sitting in his garage. If you don't have those on hand, they cost $8 to $1 new from an online supplier. Worth every penny. So let's talk about what happens next, after you've built your first system. He got his first unit running in about 4 hours of actual work. spread across a Saturday afternoon and Sunday morning. It produced power consistently for the first week. By week 2, he was thinking about building a second one. Here's why. One generator is interesting. Two generators running simultaneously is the beginning of a real energy independence strategy. Frank mounted his second unit on a slightly different axis, so that if one slows down slightly, the other maintains steady output. This redundancy is important when you're trying to replace utility company reliability. By month 3, Frank had 3 units running. Not all at once necessarily, he built them strategically. One was optimized for daytime charging of a small backup battery bank. Another was positioned to catch evening breezes through an open garage window. The third was set up as a manual assist unit, meaning he could help spin the magnet by hand on particularly windless days if he wanted to top up power. That last part, the manual assist option, is something most DIY guides skip over, but it's actually practical for someone on a fixed income. On a calm summer day when wind isn't doing the work, you can sit in your garage for 15 minutes, turn a handle, and generate the equivalent of running a box fan for several hours. It's not complicated, it's not flashy, but it gives you control. Now let's address the elephant in the room. What about efficiency? Magnetic generators, whether commercial or homemade, operate at about 10 to 25% efficiency depending on design and materials. That sounds low compared to solar panels, which can reach 15 to 22% efficiency. But here's the key difference. Your coffee can generator can run 24 hours a day if conditions allow. A solar panel works roughly 4 to 6 hours a day, depending on season and weather. Frank did the math himself. Over the course of a year, his 3 coffee can generators combined produced about 22 kilowatt hours of electricity. His solar panel array, which cost him $8,000 installed, produces about 18 kilowatt hours per year in his climate, but his generators cost him $6.09 total. That's a dramatically different cost per watt picture. The real advantage of this approach, though, isn't the raw numbers. It's the psychology of it. When you're living on Social Security and a small pension, watching your utility bill rise 8 to 10% every year feels like a slow squeeze. You start cutting back on air conditioning. You wear extra layers in winter instead of turning up the heat. You skip running appliances on hot days. You feel powerless. Building your own power generation system flips that script. Suddenly, you're not just a customer receiving a bill. You're a producer. Your garage isn't just storage space anymore. It's a power plant. A small one, yes. But it's yours, and it works because you built it. That shift in mindset is worth more than the $2.03 or $6.09 in materials. Now, the question that might be bothering you is, can you really run anything meaningful off these systems? The honest answer is, not your whole house. Not yet. But that's not the goal at this stage. The goal is to prove to yourself that you can generate electricity at home, store it, and use it productively. That foundation matters. With a single coffee can generator charging into a small battery bank, you can run certain devices reliably. A LED lighting system draws almost nothing. You could run 20 watts of LED bulbs for an entire evening on the daily output of one generator. A small laptop charges at 30 to 50 watts. Over 6 hours of generation time, you could top up a laptop battery partially or fully. A clock radio, that draws 3 watts. Your generator covers its annual energy cost in about a week. What Frank ultimately discovered, and what I think matters most for someone in your situation, is that energy independence isn't an all-or-nothing goal. You don't need to generate every kilowatt hour you consume to win. You win by reducing your utility bill, even by 5 or 10%. You win by having power available when the grid goes down. You win by understanding exactly where your electricity comes from and how much it costs. That's the practical middle ground that works for retirees on a budget. You keep your grid connection. You don't have to rewire your whole house. You don't have to spend thousands on a professional system. Instead, you build incrementally. 1 generator, then 2, then maybe solar panels, maybe a small wind turbine, maybe an earth battery system for seasonal storage. Each step reduces your bill and increases your resilience. Let me ask you this. How much would it improve your life if your electric bill dropped by $3 a month? For most people on a fixed income, that's real money. That's groceries. That's gas money. That's a buffer when unexpected expenses come up. And here's what's encouraging. Frank's 3 generators, operating freely after the initial build, have reduced his measurable electricity consumption by approximately $3.05 to $4 per month, depending on the season. That's not magic, that's mathematics combined with patience and a willingness to get your hands dirty on a weekend. It's exactly the kind of strategy that makes sense for someone who remembers when people built and fixed things themselves. Someone who understands that self-reliance isn't something you buy, it's something you do. The journey from that first coffee can to a functioning practical energy setup takes time, but the people who start that journey don't regret it. They regret waiting longer. They regret not understanding these options earlier, and they absolutely don't regret taking back control from a utility company that's betting you'll just keep paying whatever they charge. Now, here's what most people miss when they're starting out on this path. They think the goal is to go completely off-grid overnight. That's not realistic, and honestly, it's not necessary. What works for someone on a fixed income is something I call the layered independence approach. You add one system at a time, you test it, you monitor it, you let it prove itself to you. And only then do you add the next layer. Maybe you start with that Earth battery or a small DIY magnetic energy device under $100. You run it for a month, you measure the results. Real numbers, not promises. Then you add a second system, then a third. Before you know it, you've got redundancy built in, you've got backup, and most importantly, you've got understanding. You're not dependent on some contractor or electrician to keep things running. You're not at the mercy of a company that raises rates every year because they can. Let me be direct about something though. Building these systems requires you to educate yourself. It requires watching videos, reading documentation, understanding how electricity actually moves through a wire, and being honest about what works and what doesn't. The guide we've created, available in the description and pinned comment, goes deep into the specifics of Earth battery construction, Tesla-inspired resonance devices, and how to integrate hand crank generators into your home setup. It's not a quick read, it's a resource. It's something you'll reference again and again as you build, test, and improve your systems. The reason I'm telling you this is because the gap between hearing about something and actually doing something is where most people get stuck. They watch a video, they get excited, they think about it for a week, and then their utility bill arrives and they're frustrated again and they've done nothing. The people who change their situation are the ones who move from watching to building. They're the ones who spend a Saturday afternoon experimenting with a simple project. They're the ones who keep notes, track results, and adjust. You've lived 60, 70, 80 years or more. You've seen technology come and go. You've probably built things, fixed things, solved problems with whatever you had available. That instinct, that capability, that's still in you. These projects aren't complicated. They're just different from what you're used to. But the skill set is the same. Measure twice, cut once. Test small before you scale. Keep records. Trust your own eyes and your own data. Here's what happens when you commit to this path. In 3 to 6 months, you stop thinking about your utility bill as something that's done to you. You start thinking about it as something you're managing. In 6 to 12 months, you're not just saving money, you're sleeping better knowing that if the power goes out, you're not suddenly helpless. You've got backup. You've got choices. And that feeling, that sense of control, that's worth more than just the dollar savings. The utility company is counting on you staying passive. They're counting on you paying whatever they bill, without question, without option, without even knowing there are alternatives. That's how they've stayed in business this long. But you don't have to play that game. You've got the time on weekends, you've got the motivation, your fixed income demands it, and you've got access to the information and the low-cost materials you need. One last thing before we close. The projects we talk about on this channel, the Earth batteries, the magnetic energy devices, the DIY solar backup systems, the hand crank generators, these aren't get-rich-quick schemes. They're not magic, but they are real. They work, and they can save you real money on a real utility bill. The people who are doing this right now are not engineers with PhDs. They're people like you. They're retirees who decided they were done being passive. They're people who looked at their budget, looked at their situation, and said, I can do better than this. If you're on the fence about whether to invest the time and effort, let me ask you this. What's the cost of doing nothing? Your next utility bill might give you that answer, and the one after that, and the one after that. Every month you wait is another month you're paying rates you didn't have to pay. Every season that passes is a season you could have been building toward independence. The math doesn't get better by waiting. It only gets worse. So here's what I want you to do right now. If you're serious about taking control of your energy costs, if you're ready to start building instead of just paying, then grab the detailed guide from the description or the pinned comment. It's not free. It's a resource created by people who've done this work, tested these systems, and measured the results. It's worth every penny if you actually use it. And I mean actually use it. Not just read it, but build from it, test from it, adjust from it. The second thing, subscribe to this channel if you haven't already. Every week, we break down one practical, low-cost method to cut your power bill or move toward energy independence. From backup battery banks to propane alternatives to unconventional storage systems, you'll get the information you need to make smart decisions. Hit that notification bell so you never miss a new upload. The utility company isn't going to wait for you. Neither should we. Thanks for watching. You're not alone in this. Thousands of people just like you are taking back control right now. Make this the weekend you start. I'll see you in the next